Stuff with right angles. We're going to learn something about cosine law and sine law. So basically, this is where we don't have any right angle triangles. So the primary trig ratios from the beginning, like I said, only deal with right angle triangles. So that means triangles that have 90 degrees. So when we have non-right angle triangles, so anything like a scalene triangle, or like an isosceles triangle that doesn't have 90 degrees, then we have to use other laws. So in this case, we're going to be learning about sine law. So basically, the sides and their angles have a ratio to one another. So side A over sine A is equal to the ratio between B over sine B, which is equal to the ratio between side C and the sine of that angle. Okay, so there's only two different scenarios where you can use sine law, and it's right here. It's when you have two angles on any side. So when you have two angles on any side, then you can use the sine law. So the reason being is because when we have two angles, how can I find the other angle easily? What do all the angles of a triangle add up to? So how can I use those two other angles to find the missing one? Subtract. So you do 180, subtract whatever angle A, subtract B, which would equal angle C. So when you have two angles on any side, you can use the sine law. And when you have two sides and an angle opposite of one of those sides. So what I mean by that is this. So if I draw my triangle, I'm going to draw it over here. If I have my two sides, say this is 20 and this is 18, I need to have the angle that is opposite to the side. So if I have A, B, C, what angle is opposite to 18? What angle is opposite to 18? What's across from it? A. So let's say this is 38 degrees. I can only use the sine law if I have two sides, but the angle, which in this case angle A, has to be opposite from its side. Okay. So I have 18, right? So I cannot use angle C, right? Say if C is 38 degrees, I can't use the sine law. Because if I go across, do I have a value for that side? No. Yeah.
Why didn't we use angle B then?
We can use angle B. That's what I'm saying. You can use angle A or B. Because if you look across from it, it has a value for the side. Yep. So if the 20 is over here, Rita, then you can use angle C if it's given to you. Yep. So this first part of the sine law, as you guys see, all the sides are at the top. So you're going to use this part of the sine law to find your sides. So to find your angles, all you're going to do is flip all of them. So you can have sine A over A is equal to sine B over B, which is equal to sine C over C. So you would only use this part of the sine law to find your angles. And I'll show you guys what that looks like. So whenever we have a triangle with the angles labeled, so I'm just going to give you guys a general idea of how to find your sides easily. So I'm going to draw a random triangle. So let's say this is angle A, angle B, angle C. So when you're notating the side, it's going to be in a lowercase letter. So side A is going to be opposite of angle A. So side A is going to be over here because it's opposite from its angle.
So whatever the opposite is.
So where would side B be labeled at? Yep, so down, so B would be over here. Well, there's no hypotenuse anymore because it's not a right angle triangle. And where would side C be labeled? Right here. So your sides and angles are always opposite from each other. So big A is always opposite of little a, and big B is always opposite of little b. I'm gonna keep this up for a bit. Yeah.
So then, like, the small a represents the side, right?
The small letter represents the side, and the big letter represents the angle. Let's see if we can apply this right now. So in triangle ABC, I know angle B is 43 degrees. So we see the uppercase B, that's 43 degrees. Angle C is 73 degrees. Okay, side A is 25 centimeters. So what part of the triangle is 25 centimeters? The bottom.
It's not showing on the screen what you're doing.
Oh, is it frozen? That's sad. Oh, there we go. So that bottom part is 25 because it is opposite from angle A. And it's asking me to find C. So where am I going to label C? How would you guys describe it in words? You guys are doing like...
Well, this one. The opposite.
The side between A and B. There we go. Okay. So we have side A. However, do we have angle A given to us? No. Do we have two angles already given?
Yeah.
So how would I find angle A? Olivia?
Implement everything into the.
Okay. Not yet. We can't apply the law yet. Olivia, how do you find angle A?
Like, minus 43 minus
Oh, yeah.
So what is 180 minus 43 minus 73? What does that give us? Ashton? 64. So angle A is 64 degrees. So when you're using the sine law, you guys notice how there's like three of them, like A over sine A, B over sine B, and C over sine C. Technically, all you really need is two of them. One has to be completed with the side and the angle, and the other one just has to have the side or the angle. So because we're finding the sides in this case, I'm going to start with my lowercase at the top and then the sign at the bottom. So what do we have fully given?
The A.
The A's. So I have A over sine A, and because we're finding C, it's going to be C over sine C. So I know that my measurement for A is 25, and sine of A, which is sine of 64, because angle A is 64. It's lagging today. Why is this lagging today?
I mean, you can do it on the board. It's like,
No, it's not bad.
oh, well. I think
So I don't know what C is, so I'm going to have C as my missing one.
I thought you knew.
Is this gonna work?
So, no, I'm very clever.
Why is it not working? So what are we trying to isolate for?
C.
It was just working. What the hell happened? Lame.
Guys, I still think my idea was the best.
No, they're awake. Okay, I don't know why it's lagging so much. Okay. So how do we solve for C? How do we isolate for C over here?
Would we have to do the bottom side instead of using the thing? Like, move it over, like.
So how do we get rid of sine 73?
Multiply it?
Multiply both sides by sine 73. So I get 25 times sine 73 divided by sine 64 is equal to C. So what you're going to do with your calculator is you're going to do the top part first. So 25 times sine 73, and then divide that answer by sine 64. And then round it to the nearest whole number because it's saying round to the nearest centimeter.
Let's see if my calculator was correct. 25 times sine 73 dash divided by sine 64.
So Ashton got an answer.
I got an answer. I don't think it's right though.
Olivia, what'd you got?
I got, wait, so you rounded to
Round it to the nearest centimeter.
26.
So round nearest centimeter. Which, yeah.
I
You got
that
27?
one. I got
27? 27? Okay, 27. Cool. So the answer is C is equal to 27 centimeters. Not working again. So for example 2, so we have triangle DST, so you have to draw a triangle. Yep.
Yeah, I've heard triangle.
I'm not always going to give it to you. So you have triangle DST. So we know that angle D is 47. So wherever you see the uppercase D, doesn't matter where you put it, as long as you're able to label it properly. So angle D is 47 degrees. We know side D is 78. So where's 78 centimeters going to go?
Across from angle B.
Yep.
Okay. 75.
And side S is 106. So where's 106 going to go? Between D and T. So it's asking us to solve for the missing angles to the nearest degree. So what is the set that we have complete? Olivia? D. So because we're finding the angle, my sine of whatever is going to go at the top. So I'm going to get sine D, which is sine of 47, divided by 78 is equal to sine S divided by, yeah. You can always flip it, doesn't matter. But if you flip one of them, you have to flip all of them.
But if you don't flip it, you'll get this.
Yeah, except you'll have your variable at the bottom, which some of you don't like. So that's why I like to move it back to the top
So how do you know
when it's finding an angle. So how do I isolate for sine S? By?
106.
Yep. So I'm going to get 106 times sine 47 divided by 78 is equal to sine S. So you guys are going to get a decimal for this. Can someone tell me what type of decimal they get when they do that operation? Olivia? 0.999.
I got 9.7.
0.9938.
Yeah.
Yep.
How did I get 9.6?
So do your numerator first and then divide it by your denominator.
106.
So because we're finding the angle, I'll show it to you after. Because we're finding the angle, how do I find the angle using sine? What button do I have to press on the calculator? Yep. So angle S is equal to sine inverse of 0.99389. And can someone tell me what that gets us to the nearest degree? 84?
Yeah.
Do we agree? 84 degrees?
Yes.
So angle S is 84 degrees. Yes, Rita?
Like, when we have 0.993, how do we tell, like, what decimal places we should?
It's fine if you round it to like a couple because your degrees is going to be generally the same.
It would always be the same. So, like, if you stopped at, like, say 3, would it be not?
So if I take sine inverse of 0.993, it'll give me 83. So it'll be off by a degree.
Would that be like losing?
I'll tell you in the question.
Okay.
How do you get it?
You got 83? What do you mean input? Oh, so in some calculators you have to do the number first and then second function sine. At the top.
Yeah, we just still roll. No. How do you isolate for this? You have to isolate for this. So to do that, you have to multiply this by this. You multiply this by this? No.
All right, so last question. How do you find angle T now? So we have angle S and angle D. How do you find angle T? Yep. 180 minus 84 minus 47. And that gives me what? 49. So angle T is 49 degrees. Mhm. Let me just check. Okay. So what I want you to do is I want you to do the last question on your own, and I'm going to come around and check to see if you got it right. So do the last example on your own. I'm probably going to have to record this again because this was, yeah, not fun.
What's the thing of a flat line?